It was a warm and windy day in late May in the small town of Parkersburg, Iowa. Throughout the small town of just over 2,000, people were out enjoying the beautiful Sunday afternoon. However, just miles to the southwest of town, a supercell had just fired with its sights set directly on Parkersburg. Around this time, 79-year-old Kate Humphrey and her husband, 83-year-old Miles Humphrey, were out for a drive in their car. In just a few moments, the once bright and sunny spring day turned into a life-threatening disaster. As the Humphreys continued their drive, the large supercell to their southwest began to produce an exceptionally large and violent tornado. Outside of their car, the tornado sirens throughout the small town blared as the approaching tornado continued to widen and strengthen. In an instant, the tornado caught up with the Humphreys' vehicle. The tornado began to violently shake their car and send debris flying like arrows, passing mere feet away from their car. Then, after what felt like an eternity, the tornado finally passed narrowly to their south as they narrowly avoided a disaster. In just 70 minutes, the over mile-wide EF5 tornado destroyed nearly half of the small town of Parkersburg during its over 40-mile path, leaving 70 injured and 9 dead, changing the small town of Parkersburg forever. In the days leading up to the 25th, meteorologists began to cite the potential for major severe weather on the horizon. On the Day 5 outlook, issued on the 21st, the SPC delineated multiple potential areas across multiple days where severe weather could be likely. The outlook noted that the shear and instability combination should be sufficient for a multiple-day threat for relatively widespread severe storms. Then, on the Day 3 outlook issued on the 23rd, forecasters noted a 30% chance of severe weather over much of Iowa. In this outlook, the SPC noted that the combination of the moderate to strong instability and moderately strong deep layer shear indicated the potential for supercells and/or large bowing line segments capable of large hail, damaging winds, and a few tornadoes. As time went on, forecast models continued to better hone in on the significant severe weather potential for the 25th. The models showed that a strong, negative tilted upper-level trough was set to move across the upper Midwest, bringing potent severe weather mainly to parts of Iowa and Minnesota. Negative tilt troughs are typically more conducive for severe weather than other types of troughs because a negative tilted trough typically means that strong surface low is developing, which results in a large change in wind direction from the surface to the upper atmosphere. This aids in the formation and maintaining of supercell thunderstorms. Additionally, the large ridge that had been in place over the region for the previous few days that had stunted rain and severe weather was set to break down, which will allow for multiple cold fronts to move through the region. As the 25th continued to loom nearer, the potential for a significant severe weather event continued to rise. Then, on the Day 2 outlook, issued on the 24th, the SPC noted a 30% significant risk for severe weather over a large portion of Iowa and southern Minnesota. In the outlook, the SPC noted that numerous thunderstorms should initiate along low-level convergence zones along the warm sector, just ahead of the cold front and along the warm front. The discussion also noted the potential for a significant low-level jet to be present throughout the area, bringing ample low-level wind shear needed to produce significant tornadoes across the region. With the potential for a significant tornado day on the horizon, forecasters continue to ramp up their forecasting message. On the morning of the 25th, the SPC issued a new outlook, which included a 10% risk for significant tornadoes over northern Iowa and southern Minnesota along the Triple Point region of the system. The Triple Point is a region of enhanced low-level wind shear near the intersection of two surface boundaries and a low-pressure maxima in a severe weather system, which usually indicates an area of heightened significant tornado potential. Additionally, across the region, bulk shear values of over 50 knots were present, and cape values reached nearly 3,000 joules per kilogram under the Triple Point in northern Iowa. Models had varied widely in the days leading up to the 25th, with the Euro model showing much lower cape and thus severe weather potential, and the GFS showing much higher cape and thus higher severe weather potential. In the end, the GFS ended up being much closer to the actual observed values, which indicated a concerning trend. As the afternoon went on, the clear skies throughout the region continued to allow the environment to destabilize. Additionally, 0 to 1 kilometer SRH values in the near 200 range were present, suggesting that the shear environment was sufficient for tornadoes. As the afternoon continued onward, cumulus clouds began to bubble across northern Iowa as the cap started to break down with the oncoming shortwave. Then, at 12:43 p.m., the SBC issued a mesoscale discussion for a large portion of the main outlook area. In this discussion, the SBC noted that tornadoes would be possible, especially over northern Iowa and southern Minnesota, where backed low-level winds would be more conducive for tornadic potential. Then, at 3:30 p.m., the SBC issued a PDS tornado watch for most of Iowa. PDS, or Particularly Dangerous Situation Watches, are issued when the conditions are favorable for specifically strong tornadoes. The watch noted that destructive tornadoes were possible with any supercells that fired in the warm sector. At around 3:50 p.m., supercells began to fire along multiple boundaries in northern Iowa. A cluster of multiple thunderstorms began to continuously merge and interact with each other in northern Iowa. The cluster continued to interact and merge until a more dominant cell to the south began to take over. Immediately, it was evident that this supercell would be a major issue as it continued eastward through the afternoon. The supercell continued to intensify, and at 4:22 p.m., the first tornado warning was issued for the storm. Around this time, the supercell began to interact with the surface boundary draped from west to southeast, which allowed for significantly enhanced low-level spin. This surface boundary, in combination with the enhanced low-level jet, gave the supercell more than enough low-level shear to produce significant to violent tornadoes. As a result, the supercell began to rapidly produce a significant mesocyclone. Then, at 4:48 p.m., the tornado touched down 2 miles south of Applington, near the Butler and Grundy county line. Even near the beginning of the tornado's life, the violent tornadic vortices were already highly evident. As the tornado moved east of Applington, it carved through agricultural fields, leaving pronounced cyclodial patterns in the corn stubble. The tornado then began to expand rapidly, with swirling grass and farm debris signaling a violent tornadic vortex. The tornado then advanced into Parkersburg, escalating to an EF5 intensity and transforming into a massive wedge-shaped tornado just before 5 p.m. The tornado then ravaged the southern part of town, obliterating numerous homes, businesses, 2 banks, and a high school, effectively leveling the south side of Parkersburg. In town, a sturdy metal-framed industrial building in the process of being converted into a church was completely destroyed at EF5 strength. Its steel beams were twisted, sheared, and hurtled off the foundation, reduced to a mangled heap. The tornado also wreaked havoc on Parkersburg's residential areas, demolishing entire neighborhoods at EF5 intensity. Rows of homes were erased, leaving only basements in some instances, even where houses had been secured with bolts to their foundations. At one residence, a rebar support embedded in the foundation was found broken in 2. Additionally, hardwood trees across southern Parkersburg were stripped bare and debarked, and shrubs were torn from the ground and shredded in places. In town, CCTV from inside the Parkersburg bank showed the tornado as it ripped a wall off the bank. In another video angle, taken from an ATM machine outside the bank, showed a house being engulfed by the tornado at nearly max strength. As the tornado continued to ravage the town, it struck Applington Parkersburg High School. The school suffered severe EF4 level structural damage. Nearby, reinforced concrete light poles were snapped and dragged across the ground, evidence of extraordinarily powerful low-level inflow winds. As the tornado exited the eastern edge of town, it struck a golf course and a recently developed subdivision. Here, several large, well-constructed homes with anchor bolts were completely swept away, including one built with superior construction techniques that left no visible debris near its foundation. At another home in the subdivision, a concrete walkout basement wall was partially collapsed and the basement floor showed cracks. Debris from town was strewn in long, windrowed streaks across fields, much of it reduced to tiny fragments, some as small as coins. The tornado, estimated to be about 7/10 of a mile wide at its peak in Parkersburg, claimed 7 lives, several of whom sought refuge in basements. After devastating Parkersburg, the EF5 tornado forged eastward into New Hartford. The destruction of trees between the two towns was nearly total, with entire rows toppled and torn from earth, roots and all. Along Highway 57, pavement was stripped from the ground, and telephone poles, still leaning in the direction of the funnels years later, bore witness to the tornado's violent nature. The ground scouring during this stretch was severe, leaving some of the deepest cyclodial marks ever recorded in crop fields. Outside town, several rural homes were erased, swept completely away, and a granary was reduced to rubble. Upon reaching New Hartford at 5:09 p.m., the tornado, still at EF5 strength, tore through a housing development on the town's northern edge. Here, multiple well-constructed homes, secured with anchor bolts, were obliterated, leaving no trace. Additionally, vehicles were hurled great distances, mangled beyond recognition, with some reduced to mere frames. In one case, a home's basement contents, including the homeowner who tragically perished, were swept away. At New Hartford Cemetery, numerous headstones were knocked over, and trees and shrubs were entirely debarked. The tornado likely retained EF5 level destructive power for much of its path through New Hartford. As the tornado moved beyond New Hartford, it then weakened significantly, passing just north of Waterloo and Cedar Falls. Here, a local captured footage of the less organized and now broader rotation of the tornado as it began to weaken. The tornado's width then shrank to roughly a 1/4 of a mile wide, and damage in this rural stretch was mostly minor, with a few farms experiencing EF2 level impacts. However, even with the weakening stage, deep cyclodial marks reappeared in farm fields around this time. As the tornado approached Dunkerton, it veered east-northeast, bypassing the town and expanding to 1.2 miles wide. Here, the tornado briefly regained strength, inflicting consistent high-end EF2 damage on several farms. Numerous hog containment structures were also demolished, and a few homes suffered partial collapse of exterior walls. Additionally, in this location, mud and corn stubble, lifted from fields near Dunkerton, were plastered thickly onto fences, power poles, and houses. Then, just before reaching Fairbank, the tornado abruptly dissipated at 5:58 p.m. after being on the ground for approximately 70 minutes and traveling over 40 miles. In the direct aftermath of the tornado, the devastation was evident, especially throughout the small towns of Parkersburg and New Hartford. 7 people were killed in Parkersburg and 2 were killed in New Hartford, where the housing developments were destroyed. In total, 288 homes in Parkersburg and 88 in and around New Hartford were damaged or destroyed, according to local officials. In addition, the National Weather Service's assessment determined that the tornado was an EF5 with estimated peak winds of about 205 miles per hour. It was also determined that 17 homes and an industrial building sustained EF5 damage along the path. According to FEMA and Iowa Homeland Security and Emergency Management, damage was estimated at $6 million in northern Iowa, including more than $3 million in Butler County alone. The Parkersburg tornado was the first F5 or EF5 tornado in Iowa since the one that hit Jordan on June 13, 1976, and the second deadliest in Iowa since official record-keeping began in 1950. The deadliest tornado affected the Charles City area on May 15, 1968, and killed 13 while producing F5 damage. In the end, the Parkersburg tornado became one of, if not the most, devastating severe weather events to strike the state of Iowa in recorded history. The immense impact the tornado left on the small community of Parkersburg will last forever. Even 10 years after the tornado, the community was still continuing its rebuilding efforts. Incredibly, it was reported in 2018 that the population had risen to nearly 2,100 people, the highest in the town's history, even in the wake of the EF5. Additionally, nearly 90% of the newly rebuilt homes in Parkersburg were constructed with a tornado safe room somewhere inside. The city's success was more than determination, it was about gratitude, FEMA stated in 2018. And now, even 17 years later, the town continues to remain resilient and stronger than ever, even after their town was changed forever by the May 25, 2008 EF5 tornado. As always, thank you guys so much for watching. With the recent success on the Enderlin EF5 tornado, it really drove me to make a new one really soon, especially this EF5 one. I decided to pick out another EF5 tornado and make a video. Likely more of those are coming up soon, so if you guys keep liking and watching, I'll definitely be continuing to make these videos as consistent as possible with my pretty busy schedule with swimming and school and all that. But I really appreciate all you guys' support on all my videos here. For this video, I just kind of, like I said, wanted to dive into a more famous one. I think I'm going to try to do a couple more of these as we continue on through the winter months and then come back into some more tornadoes that actually happened, like the Enderlin and a couple of those that I made from this year. I like making those recent ones as well, but these old ones are always really fun to dive into and show the impacts and stuff. Anyways, thank you all so much for watching, and I'll see you in the next one. Goodbye.